Today we're going to see this problem that you see on the screen is a three-dimensional mechanism. And what we would like to do is to go over the complete solution of this problem, not only in the analytical way, but also using the software to be able to produce a three-dimensional working mechanism from scratch, meaning we are going to create the parts and then we're going to create also the models in the computer for analysis. So let's get started. In here you have this part in here that has a motor that rotates around here, and this in turn is connected to a collar down here. So when this rotates, the collar will oscillate back and forth. Now, it has two joints that can pivot these points in three dimensions. So in this particular case, the rod BC has a length of 24 inches and is connected by these ball and socket joints to this rotating arm AB. As it rotates at a constant rate, the angular velocity of this motor that rotates the arm of AB is 10 radians per second. The question here is, what's the velocity of the collar C when theta is 90 degrees? Well, based on what we have been doing, well, we can do much better than finding the solution in one position, right? And that's exactly what we need to do. We need to find the position of this and the data for the velocity and acceleration of the collar C, not only when theta is 90 degrees, but when theta is 10, 20, 30, all around. And that's what we need to do. So we'll combine this solution with the software. Okay, let's take a peek in here. Very quick review. In this case, what are the velocities of a rotating body about a fixed axis? Of course, if you have a rigid body like this, and you consider this point over here, the velocity of this point has to be omega cross r. So you have omega coming out of the board, or rather the screen, cross into r, you're going to get the velocity this way. That's what this is. Another just short review of the concepts in here. If this is a rigid body and we define this point where the body about which the body rotates, or any point that we want on the body, we can actually represent the dynamics and study this